This is going to cover a little bit about Linux kernel exploitation, specifically using an uninitialized stack pointer. I thought it was an interesting exploit, but I'll get to that. So this is a 20-minute talk, so I'm going to blast through as much as I can. With a quick intro. I'm Case. It's pronounced Case. The spelling is Dutch, and it's my grandfather's fault, but you can see me on Twitter there. I've been coming to DEFCON for quite some time. Started participating in Capture the Flag in about 2003, and along with the rest of Team Last Place, we won CTF in 2006 and 2007, so that was quite a bit of fun. But since we played CTF so much, I rarely actually went out to go see any talks or try to give any talks, since we were doing CTF the whole time. But I still play in quals because that's fun. I'm a member of the Ubuntu security team. I started that in 2006. So my background is in trying to get compiler hardening in better shape for Ubuntu, and now I'm looking a little bit more at kernel hardening. So a quick overview of Linux kernel exploitation. The main goal for any kind of kernel attack is to get control over execution flow. Usually you can just set the user ID of the process you're using to 0 and you're root, and you have full control over the system. But actually finding targets to do this is what's tricky. You need an arbitrary right to start with, and then going from there is what makes things more fun. So with an arbitrary right, once you've got that, the way to change program flow is to change function pointers. So you can aim the normal operation of the kernel into something that you have written as the attacker. Function tables are great for that because they're just lists of functions that if you can find a way to trigger that function, then you have managed to trick the kernel into running your code. One of the first ones that I played with a bit was security ops, since I was familiar with the Linux security module interfaces. That's basically for SE Linux, AppArmor, other LSMs use the security ops function table for high-level actions. So I like replacing the ptrace access check because it was up at the top. It didn't require too much cleanup after you used it. There's plenty of other things. You could use the IDT. There's a good FRAC article on that. There's plenty of stuff to read on that. But my favorite at this point is now using a single sock struct. So if you can create a socket, you've got the destructor when the socket goes away that gets called. And if you can overwrite that function when you close the specific socket, it'll actually run the code that you wanted it to run. And it's very easy to find that function because it's exported by the kernel for you to see. But all that's unimportant if you don't have a flaw. Obviously, you need that arbitrary right to begin with. So I started looking at interface boundaries, where things make transitions, and I was especially interested in copy from user, because that's where you're pulling information